Now we next move to guideline number 3 for simplifying radical expressions. And it can be stated in the following way, that you never want to leave a factor of a radicand that can be expressed as something to a power where that power matches the root or the index. So we'll take a look at a couple of examples to clarify that. And our first is the square root of 18. Now what we'll be looking for will be factors of 18 that will be perfect squares. And squares because the root or the index here is 2. I think you can see that a perfect square factor of 18 will be 9. So we'll rewrite then 18 as 9 times 2. Now you won't need to do this normally, but let me just rewrite then this as the square root of 3 squared times 2, because this will then tie to the explanation I gave for this guideline, that you see the power on the 3, which is 2, matches the index. So what we'll do then is to rewrite this using the product property as the square root of 3 squared times the square root of 2. And we know that the square root of 3 squared will simplify to 3, so we then have 3 times the square root of 2. And for our second example, we have the cube root of 48. And we'll be looking for factors of 48 that are perfect cubes. And I think you can see that 8 is a perfect cube factor of 48, so we'll rewrite this as the cube root of 8 times 6. And again, you won't need to normally put this step in, but just to illustrate again how it matches the guideline, I'm going to rewrite 8 then as 2 to the third power, then times 6. So you can see here that the power on the 2 matches the index or the root. So we'll rewrite again using the product property. So we have the cube root of 2 to the third multiplied by the cube root of 6. And the cube root of 2 to the third we know to be 2. So then our final answer will then be 2 times the cube root of 6.